Most of the people know that rare earths are used in modern technology, but very few understand where they actually matter. The rare earths are not everywhere in the products. They are only in very specific components, but those components often determine the performance of the entire systems. This is a key idea. The wires are not widely used. They are critically used. Now, let's start with electric vehicles. A modern electric vehicle motor often uses neodymium iron boron manganese. And these magnets contain rare earth elements such as neodymium and dysprosium. Why are they used? Because they provide high magnetic strength in a compact size. This allows motors to be more efficient, powerful, and energy dense. Now, here is the important part. You can build an electric motor without rare earth, but the motor will be larger, less efficient, and often more expensive at scale. This is not a binary question of can or not. This is a question of performance trade-offs. Now let's look at wind energy. The offshore wind turbines increasingly rely on performance magnet generators. A single large turbine can contain hundreds of kilograms of rare earth materials. Why? Because high efficiency reduces energy loss, and lower maintenance is critical in offshore environments. Again, alternatives exist, but they often result in higher weight, lower efficiency, and more complex maintenance. Now move to aerospace and defense. Rare earths are used in jet engine components, guidance systems, radar systems, and advanced sensors. According to U.S. Department of Defense disclosures, an F-35 fighter jet contains hundreds of kilograms of rare earth materials. These materials enable high temperature resistance, precision control, and signal stability. Without them, the system may still function, but performance degrades, reliability decreased, the operational limits become tighter. Now let's examine consumer electronics. Smartphones, hard drives, and speakers all rely on rare earth magnets. These components allow devices to be smaller, tighter, and more energy efficient. Again, a substitute exists, but they reduce performance or increase size. Now step back and look at the pattern. The rare earths are not critical because they are irreplaceable in theory. They are critical because replacing them comes at a cost. That cost appears in three forms: lower efficiency, higher system complexity, reduced economic competitiveness. This lies to a deeper insight. In modern industry, the most important materials are not the one you cannot replace. They are the ones you cannot replace efficiently. And efficiency is everything because efficiency determines cost. The cost determines skill, and skill determines industrial dominance. That is why rare earths matter, not because they are rare, not because they are irreplaceable, but because they sit at the intersection of performance and economics. Now consider a counterfactual scenario. What if rare earth supply become constrained? Industry will not stop; they will adapt. But adaptation comes with trade-offs. Electric vehicle may become less efficient. A wind power system may become heavier and more expensive. A defense system may face higher costs and longer development cycles. This is how constraints reshape industries, not by stopping production, but by shifting performance, cost, and competitiveness. And that shift can change global industrial balance. This brings us to the next and the most important question. If rare earths are so critical to performance, where are the real bottlenecks in the system? Is it mining? Is it refining? Or is it something deeper inside the industrial chain? In the next episode, we will explore whether rare earths could become the next strategic bottleneck in the global economy.